All right, coming up next for our first talk is Wasabi with Amped Up for Learning Radio.
All right. Is this thing working? Yeah, okay. All right. Well, thank you, everyone. Welcome to Amped Up for Radio. Oh, yeah, now I can hear myself. Perfect. So I hope everyone's excited to learn about what not to do about educating people in radio, because that is the entirety of this talk. If you wanted something else, I'm sorry, but we are here. And I am very excited because this is something that I try to do regularly. I do a lot of volunteering. We'll get to that in a second, but radio is something that we just don't see in the educational space as much anymore. I mean, we have radio class across the way. That's great. A lot of people getting their licenses, but in the academic space, it's kind of lacking. So about me, I am a security researcher. I have been doing embedded and IoT research for over 10 years now. I know, not that much time. Some of the folks here have been doing it way longer. But in that time, I have found a pattern on the way things, work and don't work, and especially with trying to mentor the next generation of people who are going to be participating in that same field. I'm also a radio operator. I'm a ham radio extra, so I love radio. If you don't get that feel through the talk, I'm sorry, I'll take notes and change the slides, but I love radio. Radio is really cool. It's taking something that just sticks up in the air and making it transmit energy that you can then decode. It's awesome. So I love this stuff, and that's why I want to make sure people have that interest, especially for the students who are coming into the industry. I'm also a cloud engineer, so a lot of the stuff I do by day is cloud engineering, and by night I do all this IoT security research. So it's a big difference, but sometimes they overlap. And most of all, the reason why I'm able to do this is because I am a competition creator. If you've heard or participated in CPTC or CCDC, that is me. Well, not just me. There's a huge team of folks. A lot of folks here have helped or do help with organizing these events. And the most important thing to me is these give back to the community. So all of the stuff we're going to be talking about for the next hour, well, you're going to be listening to me talk, is all focused on those competitions. There are others, but these are the ones where students are put into a fake world and they have to manage these systems they don't understand. So here's the rough agenda. Now I'm going to show you a challenge, and I will buy whoever wins this challenge. If you win it, lunch. I will give you money, and you will get lunch. I don't think you're going to be able to solve it, because first, there's not a lot of pixels, but we'll see what we can do. So we're going to do the background on that, and then we're going to go over a couple of different competition challenges that were done in the past couple of years, and what went wrong. That's the biggest thing. At the end of this talk, we're going to talk about what was cool about them, and then what went wrong, and why did they not work quite right. And that's why I'm making this a challenge, because something didn't quite work right here. All right, I'm going to leave this up for a second. This is the challenge. If you take your notes, this is a perfect example message. You can try to take pictures. I'm looking up here, and I don't see a lot of pixels, so the next slide is going to be really rough. But if you want to take pictures and you want to try to make this thing scare the crap out of me, oh, am I allowed to say that? But it will buzz, and it is really loud. And so if you make it buzz, you just raise your hand and you tell me, and I will be like, wow. But you're going to have the harder version because the students who participated in this challenge had a whole document. I'm only going to give you one slide from that document. There it is, and that's why I said I don't think there's enough pixels in this presentation. So I didn't plan for that, but yeah, we'll see. So I'll give everyone a second to take a picture of that and see if you can try to figure it out. I want this to be fun, so those of you who are more the CTF type, you have a challenge in front of you. This thing is fully functional. It is the actual functioning version prototype that we made working for CPTC last year, where we were in an airport and there were 5 baggage claims the teams had to hack. I should probably also be talking right in front of the microphone so you can hear me a little better. But this was one of the prototypes, and it works. It's fully functional. It has a radio. It runs off of a Raspberry Pi, and so you can actually do a couple of things with this. 1, you can make it buzz. 2, you can change all the text on the screen. And 3, you can get root on the system, because of course I made sure the whole thing is realistic and everything runs as root. So you have full control over this if you can get it. There's the protocol. There's the fields. Good luck. And with that, here's a donkey, because I typed in good luck, and then that was the suggested picture for PowerPoint. I don't know why. They're just like, there you go. So I used it because that was their suggestion. Thank you, AI. But you will have the whole time here. And if you get close, come up to me at the end of the talk and let me know how close you got. I can tell you if you were on the right track or not. But I'm hoping someone will make this thing buzz and scare me. All right. So radio is pretty ubiquitous. It is everywhere. We are using it right now. We use it every day for our home. We do all sorts of things with it with our cars, with Bluetooth. There's a lot of standards, and everything is a bit abstracted these days. If someone was to tell me, like, how many people know the waveform and structure of how Wi-Fi works? Anyone? Okay. And that's the problem. We do not have a lot of skills in radio anymore. The deep internals of how all these technologies function is a bit of a mystery. It's magic. You make something go over the waves, and it happens. So that's a problem because, as we'll get to in a second, the people who understand this wizardry are getting older. And first, again, PowerPoint suggested a couple things for me, and I just said yes, because their new Copilot thing is really, sometimes it's amazing and sometimes it's really terrible. It made the graph that shows just 2 line charts that really aren't changing. Really super useful. Thank you, PowerPoint. But what these charts show on the left is the average age of a radio operator. And you may not be able to see the pictures, but I can tell you the first 3 are under 30. And it goes up from there. Now, obviously, there is going to be an increase. When you retire, you're going to have more time to do things, and a lot of people get into radio at that point. But that's still a problem. You can see the big jump. That's the over, 65. But if you're retired, you're not really contributing to all these skills and things like that. That's fine. So we go to the other side. This is the engineers from, this was a survey that was done in 2023 and 2015 on age distribution of embedded radio engineers. This isn't like people who are like setting up telephone things and like this is the actual people designing the chips and the protocols and the waveforms. And the useless chart, which while amusing, actually shows that there's about 40% of the people are under 55, and the opposite is true. You have over 50 making the majority of the radio designers. So what happens when these folks start retiring en masse? Who's going to take it up? There's obviously a gap, and that gap is growing by the chart which you see with radio. There is a major problem here where these things become more magic. And the analogy of a wizard is it should not be what we're seeing. People should understand these things, and they should have the interest and background and ability to. The problem is these things are not easily approachable. You have to either go through a lot of engineering, or you have to be really, really stubborn and determined to explore these things. So I wish, again, that chart was better, but Copilot gave me that. But we can see the actual chart. It seems to be improving, but this is the problem with charts. You don't really know, especially when they're terrible charts. But there might be some slight increase in people in the last few years doing radio, but we need to make sure that's encouraged. And so the folks in college have that ability to learn these things. So here's the problem. Basically, problem statement. You can get a radio license, and that gives you the ability to explore. But radio is primarily voice. If you want to start doing encrypted stuff or you want to do packet transmission, it's extraordinarily limited. You can't do too much with ham radio. Like, there are some edge cases where you can do extra channels on Wi-Fi and you have to make it an open channel and things like that. Those aren't really the main use cases of ham radio. So then there's other things that are approachable, and these are just cheap things. A flipper is pretty affordable, and it can do packet replay pretty well. But that's the extent of it. You can't really learn all the modulations and do all the different things. But there's something new, and this is a shout out to the Mesh-tastic folks. It's really cool, and the community is extremely live. And what I mean by that is there's constantly people. The community, there's a local one for LA, SoCal, I guess. There's also community for pretty much every region, and they're extraordinarily active. And the thing I love about Mesh-tastic is get some cheap stuff off of Amazon and you learn it, and that's the gateway. You now have this device. You can now do mesh, communication, and then you're going to want to do more, and you're going to want to tinker, and it really opens up that opportunity. I was skeptical of it at first, and we'll get to that, but it is probably the best right now area for people to be learning in radio, and I'm just really happy that that program exists. Well, not program, but that community exists. So here's ham radio. Here's the challenge with ham radio. Again, primarily voice. I've listed a few protocols here. It's, how many people have messed with slow scan TV? Two. Once. Yeah, exactly. And so it's a lot of fun. You used to be able to point at some of the helicopters flying around, like the news ones, and they used to be radio operators, so you can actually have the uplink, or the downlink, I guess, be a slow scan, and you can actually see what they were seeing. That doesn't really happen anymore, but slow scan TV is a thing. But my problem with ham radio is not that there's really a problem, but the software is complex. Like, you'd look at that and knobs, and that could be mission control right there. And also, it's not exactly the most modern. This picture where they're downloading, I believe it's the slow scan TV software. That's from 2014, and that's Windows XP. So that's not the exception for ham radio tools. There are a lot. I remember using like D-Star or a few of the other ones, and like some of the recommended stuff is like run CentOS 6. And it's because the drivers are custom made and things like that, and it's very specific. So not necessarily the most modern, but then we have the alternative, Meshtastic. It uses LoRa and MQTT to communicate. There's a lot of other things to that, but just for high level, simply put, those things mashed together, you have Meshtastic. It's really cool. And it's a rapidly growing community. I did a lookup across the world, and there's huge numbers of people setting up these nodes and in different communities. And it's affordable. You can spend less than $100 to get 2 nodes, and then put them in a little project thing. Maybe you get one, but it's really, really cool. And it's also a great learning platform, because if you see people with, around here with the little like BlackBerry looking things, that's Meshtastic, and they're sending messages to each other. It's really accessible, really affordable. So how affordable and accessible? Well, these are just some of the nodes. There's overlapping nodes, so they kind of get covered up, but there's a lot of people just doing hosting of these nodes. That's not just users, that's people just hosting nodes. So that's really cool. Probably the most affordable approach right now. Then there's the really cool one where you're really going to learn a lot, and that's software-defined radio. And $200, $250 for a hack RF, not necessarily approachable, but it's not too bad. But then if you want to get the really good stuff like a USRP, that's $2,000, $4,000. Nobody as a student is going to just have $4,000 that they can drop and put into their use cases. The other fun thing is, once you get that thing, it's a software-defined radio, so you have to use the software. That software is GNU Radio Companion, which is probably the most complex and coolest software ever, but it again is not approachable. Very high learning curve, and if you want to do some of the hobbyist things, you have to get all these different kits. And then those kits come with like a specific version of something that works on like Arduino IDE, like from 5 years ago, and you can compile it with these specific tool chains, and they give you a CD because none of that stuff's available anymore. And now you have a working radio. This, in fact, had the same suffering point. This uses a CC1101. I might have forgotten a 1 there, but it took us like a month to get the software to compile on modern Linux, and it was a lot. Once it was working, it was great, but you have to do all these things to get radio because it's still kind of like wizardry. So you have to be very, mindful of that learning curve. And does anyone know, by looking at the blocks, what this decoder does? So this is an FSK decoder. Super simple, right? Everyone knows how to just wire that thing up and make it, demod. So yeah, it's really high learning curve. And, sometimes, especially with the stuff with filters and bandpass, you need some complex math to figure that out. So what can we do? Well, this is going to be probably, for those of you who are in radio, a little bit like very basic and boring. But for those of you non-radio, it might be a little complicated. So I'm going to go through this relatively quickly. Um, fundamentally, radio, you have something that transmits, and you use a magnet. It's magnets, electromagnetic waves to transmit. That becomes what you end up doing with modulation and all those things. Radio goes from 3 hertz to about 300 gigahertz, if not higher. And if you look at a whole spectrum, visible light is also on the spectrum. So it's really cool. Here is the United States spectrum, though. And in here, there are these little things called ISM bands, and you can't read it because we don't have enough pixels. But ISM bands are international bands that allow any type of device to be transmitting. They're not universal, but in those bands, that's where these things live, the hobbyist stuff. And with those hobbyist devices, that's where we can have our success. So again, with these things, radio basics, we create what's essentially called a carrier wave that has a fixed pattern, and then you encode that, and that creates the modulation where you are adjusting in different ways how that data is transmitted. When it comes to a receiver, you can undo all that process, and then you get the data out. And as long as you know some of the basics of what frequency and different information with that, you can decode that data. That's the very simple version of it. There's a few common things, and here's the challenge with these and why we're going through the basics. So you have FSK, which is frequency shifting, phase shift keying, and then ASK, which is amplitude shift keying. The simplest form of encoding with radio is OOK, which is on-off keying. And as the name implies, it's either on or it's off. And do that really fast, and you get data. This uses OOK because we wanted something that would be very simple for people to understand and see visually. So if we put this into a little waveform and things like that, you get all this different stuff where you can see a carrier, and then modulating it, you now have it shifting. And these are the different ways that you can do it: ASK, FSK, and such. So you can see how the different modulations visually look. But this is all computed. Radio waves don't actually look like that. That's math. So when we have a lot of radio transmission, you can start decoding these things, and then you have to get into things like error correction because it's noisy in the radio space, and so you run into all sorts of problems. But that gets into math and things. And so we're going to jump into math a little bit more. What all this actually is what's called I and Q data. And that is also put together called a complex. And that's essentially just visually vectors in space that allow you to more easily in software understand where and what things are going on. So here's I and Q data in the 3D space, and you adjust that by essentially the green dot moving it in and out and up and down, and that's what you see here. And as that shifts, that's where you get in phase, out of phase, and all sorts of things like that. It's really cool stuff, really complicated. And this stuff right here is why radio is quite a bit complicated. And I actually had given myself more time to talk about all this stuff, but looking at the clock, I don't want to go over. So if you have questions about this, when the slides are posted, they have a lot of notes and stuff on them. So I will make sure to get them to you, but I just don't want to run over on the talk. But it's really interesting stuff. And also this is why radio is so challenging for many people, because this isn't, complex math is not something that you just learn in, high school. Well, you sort of do, but it takes a little bit of understanding to jump into that. So first things first, our first challenge that we made, and this was this year, was for the Collegiate Cyber Defense Competition. The idea of CCDC is students have to defend a network being compromised actively by different types of attackers. This year, it was a nation state and that was attacking us. And we have a lot of cool history on different things. We have full phone systems, so teams have to deal with phone systems and SIP protocol and all sorts of things like that. We try to focus on a balance between realism and fun. And some of the past ones, we did Jurassic Park. I mean, Jurassic Land. Sorry. And a industrial food thing that totally was not Willy Wonka. And we did a bunch of different, things where we did a bank and things like that. And the teams have to run into these things. We've built control systems and all sorts of interesting, scenarios. The challenge with all these is that you have to balance that realism with complexity. Why are you making that complex control system versus why are you making it just simple? And I'm not saying that we predict the future, but I'm not saying that we don't. So, I'll go back one. The couple years ago, we did a shipping called Stuff on Ships, SOS. And that was the same year that right before the competition started, the Ever Given got stuck in the Suez Canal. And then another year, we did a cryptocurrency, and that was when FTX made the news. And, another year we did just this plain bank, and then Silicon Valley Bank folded right before our competition. So I think we should stop making scenarios because they happen in reality. It's kind of scary. This year was no exception. We were the Federal Bureau of Containment, and it was an SCP themed. So for those of you not familiar, like aliens and weird things happening and anomalies. And the students had a classified network that was put in caution tape that was completely, sort of, but not properly air gapped. And that was part of the scenario. And they had to keep communication open with agents in the field. We could give them radios, but of course we wouldn't. So our total budget for this learning opportunity was under $250. There's a few things that we could do. Originally, we were going to do a controlled arm to contain things and make it move via radio. That was way too much. And so we weren't able to do that. Wi-Fi Halo, it's not very common, but it's really cool. It's in the 900 megahertz band, and it's long range. So that one's kind of fun. Pretty sure they use static encryption key on the module, so it's not really good. But, we didn't have that. Hacker Fs, we do not have enough money to get a Hacker F per team and then a transmitter. So instead, true and proven, car radios, because those are cheap. And a really, really, really cheap radio. Shoestring budget, but it works pretty good. So what did we do? We built a number station. So what is a number station? Well, they're pretty old. Since World War I, they've been used. They were really popular in the Cold War. And there's a certain person who may or may not organize a certain conference called LayerOne who built a really cool one a few years ago. You should ask Datagram about that one. This was the second one. They ran this for a couple of years, and they had a bunch of challenges, and it was like one of the early alternate reality games, pretty much. The way these work, though, is it should be a one-time pad. So something being encrypted should be able to be decoded, and it shouldn't be able to be used again. Once if you're using the same encryption stuff, then it can be read and they can make patterns. So it should have a specific way of being decoded at that specific moment in time, and that should never be used again. Ours used Apple TTS to generate individual letters. And then we wrote some software that took every letter and number and transmitted them. And so one was an API server that accepted input. So the attacking team, we have a group of volunteers, the red team. And so they could have fun with it too. And then we had a scheduled transmitter that used the same API to transmit messages to the field. This is what it looked like. Really cool. So for one thing, it was kind of fun because we didn't tell teams what was going on, but their true and proven Bailal-G radio was just sitting on the desk making random noises. And then the little transmitter was stuck underneath in the back of the computer. So it was plugged into a USB port. And so I'm sure some of the teams were like, what is that thing? So we're going to try some science. There we go. Let's see if this works. So yeah, it sounds super staticky and scratchy and just like I was hoping. That was just an added bonus. We didn't do anything to make it sound that terrible. But you know what do you get? So that was a lot of fun. And it was extremely vulnerable because it's transmitting. And the codes, well, it was just DES encode, like it was just ASCII to DES. So it was very basic. And so I was hoping teams would understand what was going into the messages and then be able to decode them to see if they were valid. I don't know if teams got that far, but they did have to deal with radio. And so this was Red Team going room to room with a very overkill antenna to try to listen to their transmitters. Keep in mind, these things are for car radio. So for FCC compliance, they can't be very powerful. And that's why we did it. But that also means Red Team going room to room can't just listen to and transmit on the same frequency easily. So they had to do a makeshift Yagi to listen to the team's codes and then write them down and transmit back. So it was pretty funny. They were just going to room, and the students were looking through their windows like, what's going on? So that was a lot of fun. But we'll get to it in a minute. But there's a few things that made this a little bit of a flawed challenge. And I'd like to let people think on that until we get to the issues part. So next one up, CPTC. I'm wearing the shirt. It is a pen testing competition. The students have to act as a professional pen testing team to do analysis on different systems. We've had some really cool ones. We did one year a bank where we had actual ATMs that we reversed the protocols on, so we could actually make the teams deal with the payment system. And then one year we did, this year we did a social media company with AI. And we've done a lot of other scenarios. It's a lot of fun. The teams are put into an interesting situation because what happens if they take down production? That's the one thing versus CCDC where they have to defend and keep everything up. The other side of the coin is what if they take down prod? Well, now, do you admit it? Spoiler alert, a lot of teams do not. But we find out anyway. I'm part of the special projects team, which is making special projects. And so in the 2024 scenario, we made an airport. And so what you see here is the baggage claim system. Every airport has one. We didn't have a conveyor belt. We just had the big buzzer. These are all radio controlled. The way we set these up is they are air gapped. They actually have the transmitter. They're a Raspberry Pi kiosk in kiosk mode, so it's very simple. We did have them connected to Wi-Fi, but the teams did not have any access to the Wi-Fi, so we could reboot them if they crashed. But the way this worked was we wanted to test students' ability to understand interference, how protocols work, and most importantly, we wanted to have teams understand how modulated data is in a radio. So we gave them RTL SDRs to listen to all the communications, and then their challenge was not to re-encode everything from scratch, but understand the messages in the radio message, like actually decode the data, reassemble it, and transmit it, like I gave to you. And so their challenge was they had a transmission tool that would allow them to take all that raw bytes and properly encode it. So they didn't have to do a lot of the other layers, but I wanted them to understand. How this thing's actually wired up is pretty simple. It's just a couple of LEDs, some power, regulator, and some relays. Not anything too fancy, but it is pretty fun. The whole thing is held together with hot glue, as it should be. And this thing's actually pretty expensive. When you put it together, it's hundreds of dollars to make this thing possible. And I shout out to Balsa. He went and spent an evening assembling all of these for the teams, all 5 of them, flashing every single Raspberry Pi and making sure they all worked. And then I went from there because I was not on site. We had to set these up in advance, but it looked pretty cool. So there's our baggage claim. And the challenge was we originally wanted 1-to-1. Each team would have a transmitter and a receiver. That way it's fair. That's why they could hear it. We didn't have the budget because this, as it was over $700 just for the basic parts in bulk from AliExpress. Then it was going to be one receiver per team with the central transmitter, and then it was eventually just 5 transmitters, so the teams had to rotate in and out because we had more than that. So teams were given a slot of time to do a hour and a half analysis and receive any of the data and transmission stuff that they could do at the time. The control towers worked well, but because there was only one transmitter and it was software defined, there was a queue. And so here's the transmission system that they were given access to. It would allow you to select a channel, the frequency, and then what I called the identicode, because I didn't want teams transmitting spam to the things and just replaying messages and stuff like that. They had to have a valid identifying code. This is just a random number, but this allowed us to validate that the teams were what team was what. Because if the team was assigned to box number 5 and their code was for their team, and we would be able to identify which team. So if they said, "Oh yeah, we did it," but it would transmit it on this machine, we would know that they were just replaying messages. And then we could adjust the modulation, and then they just had to deal with the packet. So they did have RTL SDRs. Here's a screenshot of the stuff they were looking at. They were able to decode it, but we ran into some problems with that because they didn't know how to they were taking all the bytes out and stuff like that, but they weren't sure where noise started and messages stopped. That's why we gave them the prefix and suffix. But this is in the event, and some of the teams actually did it. Announcement, aliens arriving at baggage claim 0. So some teams did have some success. And then this one, flight canceled, and then base 64, garbage. So some teams were very successful at this, and it was a lot of fun. But, sometimes there's a few challenges with these things. So here's where we go into the things that did not work. So radio needs to be approachable. If you just dump a radio challenge to students, whether it's a CTF or things like that, they may work through that problem and they may be able to solve it, but what are they learning? They may not be learning very well. So with the scenario of shared resources, what happened? Well, teams were queuing up and trying to figure out stuff, but because it was a queue system, until it said transmitting, they were waiting. If their machine went off while they were waiting, was it them or was it not? It creates this confusion where there's delay for them being able to trigger the thing. If you turn on a light switch, if it waited 5 minutes to turn on, you wouldn't be sure that that switch did anything. And that's the same thing with radio challenges, is if there's too much delay for what you're learning, you don't learn anything. And then there needs to be better background. As I was trying to do with the background of radio, you really need to understand the basics. And the basics get really complicated really fast. So how do you do it? Well, we need to break things into smaller pieces to be able to educate students better. This is something that I am actively trying to do, but just as something that I've seen as someone who works in the academic space to teach people about these things. Basics of radio and how they work, especially on a embedded system level, is extremely complicated. If anyone here, I presume the majority of this room would understand how to do wireless attacks on Wi-Fi, how to get keys or things like that, at least in theory, because you could go online and find a lot of documentation, understand it, get into the more complex components of that. But if you were to try to decode raw radio packets like IoT or embedded systems, or how does Wi-Fi actually work, almost nobody here would probably be able to raise their hand. And that's the challenge, is the underlying systems are extremely complex and we take them for granted. So one of the things that we wanted to do was I had hoped that the CC1101 would be a very good SDR receiver transmitter device. And they come with a little debug that's relatively cheap. They come with a debugger that allows you to actually use it as a full SDR. It's relatively cheap, but it's also end-of-life software. So it's really hard to run. You have to run it on Windows 7 and things like that. So it's a good, relatively cheap thing, but it has its limitations. And we thought maybe we can bypass and just get it working directly in Linux. And we did, but that also made it more abstracted for students because they didn't have the resources with them to understand the fundamentals. And also, if we go back for a second, the fundamentals are these 4 blocks: frequency, channel, modulation, sync word. That's the basics of how a message is transmitted. And so they were given all these things, and I actually selected the right values, but teams were changing them because they weren't understanding those basics. And so it is very challenging to get this right. Oops. So maybe the solution is maybe wait for things until you have something like a hacker F where you can actually give them some of the basics. Because hacker Fs, and it's not just an accident they keep talking about hacker Fs. One, they're very affordable, relatively speaking, for other SDRs. But two, because they are they're used in academic space, they are also very accessible. If you want to have basics on like how to make a transmitter or a decoder or do all sorts of things with a radio, the 9 times out of 10, and that's an exact number, but you end up with a hacker tutorial. And so using the things that students can Google helps them learn, because at the end of the day, if you keep students frustrated and they don't understand the thing that they're trying to learn, they're not going to be able to succeed. And they won't probably want to come back. If you just spent 3 hours trying to figure out something, and it's a CTF, maybe you're very dedicated. There's a lot of folks in here that are very dedicated like that to CTFs. But the average student is not that dedicated. If you spent 3 hours and you had nothing to show for it, you're probably not going to go into that field. So that's the challenge. And the other challenge is buggy software. So I'm not going to go back again to the queuing software, but the queue was buggy, and sometimes it wouldn't update fully. So making radio challenges very accessible and reliable. That, again, it comes back to reliability. If we're not working on reliability, then we're not actually able to teach the thing that we're hoping to teach. Because are you experiencing a bug, or did you do something wrong? If you can't say that for sure either way, the challenge is flawed. And that's something we learned, especially from this one. The teams were doing a lot of good work, but I was having to validate all the work because the actual scenario, they weren't quite getting the modulation right, or they were on a different channel or something. They were just waiting too long because of the queue. And so it's definitely a challenge. And then the other thing that we thought was how best way to learn basics of radio, get a radio license. And the FCC, no fault to them, but you have to go through processes when you get a radio license. You can't just say, hey, I got 3 people together, let's get everyone licensed in this room today. No, you have to do some pre-work, you have to do some pre-registration and things like that, and make sure everything's ready. You have to get the forms and the tests, and there's a fee. I guess you could cover everyone's fee if you really wanted, but there's a lot of pre-work that has to get set up to make that happen. So on-demand licensing, not happening. So you could use that radio work, but again, if there's no reward at the end, why are students putting in the effort? So that one takes a little bit more work. And then the other thing that I've learned with making challenges is just because you make a really cool challenge that you can talk about at a talk later, doesn't mean it's necessarily a good challenge. I like the balance of this one because of the way it was designed. We gave teams a lot of stuff. We gave them like a 14-page booklet on how to do radio stuff and how to use our software and how to do that. So they were given a lot of information, and that's why teams were able to do a lot of that stuff. But there's a difference between making a fun challenge that's really cool to talk about and a good challenge for people to learn from. And so keeping that in mind helps, because if you want people to learn again, you have to be mindful of that. But then also, it's kind of contradictory. You also want to make something that people want to talk about later. When we did Jurassic Land, sorry, we made a scenario with a bunch of different things, and we actually made it really fun. We had a whole thing running in Open Roller Coaster Tycoon that the whole park was running out of. Each team had their own instance. And so when rides broke down, it was communicated back to their control systems that the ride was broken down, and they could turn on and off rides. And so Red Team was just turning off and on rides and things like that. So if the fences were down or the park power went out, all the rides would go down and the guests would leave or get eaten in the case that we were scenario. And people still talk about that because it was really approachable. They didn't have to understand how those components were working. They just understand this API, this server has to be protected, otherwise you get hacked. And what happens if you get hacked? All your guests get eaten. And then you can talk about that to employers. Well, I let my guests at my fake Jurassic Park get eaten. Okay, well, what did you learn? Well, I learned that you have to secure these web servers and things like that. APIs are important. And now they're talking about things and they can get jobs. And at the end of the day, what is the point of all these events if not to help students understand and be able to get skill that they don't have from school? So yeah, and it's something to remember. The other thing is things like the porta pack are really good because again, it's simplified and you can have if you teach to that or you make a scenario to something that's really simple, it's easier for students to learn from. Like, oh, do I need to do a capture and replay? Okay, all I need is the frequency. Now, if you want to decode it, it gets more layers. So my recommendation is break those things down so that each of those is a bonus point on top and it builds. That way, when the student figures out, 3 of 5 challenges, they feel really accomplished. But if they get to all the way, then they get, really, they've really learned it. This is how CTFs are in some cases where the challenges get more challenging with higher points. And it's something, the reason for that is because it allows people to feel accomplished. At least they did something, they got somewhere. But I did want to shout out to Balsa again because every time we seem to do these special projects, I'm in California, obviously. He's in New York. And I can't build all of the components and I can't fly them on a plane. TSA would not like this going through the airport. Yeah, that's my portable baggage claim, guys. Yeah, totally trustworthy. They wouldn't, they're not going to like that. And so what has happened is when we were doing the ATM, he was actually in like a whole warehouse where all the ATMs were connected, and we had screen and stuff where I was SSH'd into a jump box and doing all the dev work, and he was there resetting and testing all stuff, and we were developing together. So like, we literally had multiplayer like editing in Vim to edit things as we were trying things. And I don't think any of this would be possible without us collaborating across the country. And so I just wanted to do a shout out to him for that. But with that, I am at 44 minutes, and now is a chance to ask questions. Or you can follow me on social media, or talk to me at the end of the talk. But yeah. It is. That's a lot of questions. All right. So first question is, what is a good approachable SDR tool? I would say the PortaPack is still a really good SDR tool because it gives you the flexibility of doing replays and a bunch of manipulation directly on the device. And it's also more broad frequency than just a flipper. And then sorry, there was like 3 questions. But the second question is GNU Radio still used? GNU Radio powers way more. So for those of you who are not familiar with GNU Radio, it has a visual tool that allows you to connect things and do all the visual diagrams. That can be exported into actually a compiled program. And now you have a SDR software that can actually do the transmission and receiving for the radios and stuff like that. So you can actually, it's still used for a ton of stuff. There's a lot of really complex technical things that use GNU Radio as the back end to actually do transmitting and receiving. So you may not see it, but it's there, and it's a really good tool. It's just really high learning curve to actually get it to do its thing. It also crashes sometimes, like because the back end and the front end are separated. So sometimes you'll lose sync, but it's a really good program. So yeah, definitely take a look at it, but be prepared for a steep learning curve because their wiki is good, but it's made for people who really understand the subject. Yes. It's a PortaPack? It's a PortaPack? Yeah. Any other questions? Oh, yes. Or did you not have a question? I thought you raised your hand. Oh, no, he didn't have a question. Okay. Does anyone have any other questions? All right. Well, thank you. I will be hanging out over in the corner for a few minutes after this. But unfortunately, nobody gets free lunch because I did not hear this go off. So sorry, guys. you ran out of time. But if you got close and you want to show me what you did, I'll be over in the corner. But otherwise, thank you for coming to my talk, and I hope you guys now have some knowledge on how to make more educational learning systems, especially for radio, and maybe you learned something about radio too today. So thank you all.